Hello there, Mr. Sutton here, bringing you this lesson on the law of cosines. In this one, we're going to find missing sides and angles of triangles in two situations. One is if we have two sides and an angle between them, and the other situation is if you have all three sides. For the real-life application of this, we're going to go ahead and find the diameter of a mountain. Before we get into our warm-up, let's talk a little bit about this new law, the law of cosines. So the law of cosines is real helpful when you have two sides and an angle between them, what we call the side-angle-side situation. So here's an example of that. Let's say that we have a triangle and we know two sides, A and B, and we also know this angle between them, angle C. You can use the law of cosines to figure out the value of the third side. So here's how it works. We say that that third side, C, if you square it, so C squared, equals a squared plus b squared. And I know what you're thinking right now. This is the Pythagorean theorem, and you're almost correct, except it's not a right triangle. So there's a little bit more that we have to add on the end here to account for that. So we have a squared plus b squared, and now here's the extra, minus 2 times a times b times the cosine of c. This little bit at the end is adjusting for the fact that we don't necessarily have a right triangle. Now, the neat thing about this is it actually still works with a right triangle. If C is actually 90 degrees, so that little c is the hypotenuse, well, the cosine of 90 degrees, if you plug it in your calculator, just happens to be 0. So that would actually end up zeroing out this term, giving you the original Pythagorean theorem. Kind of neat. So here's your task, because you're going to be using this later on in the problems, but we have a warm-up to do here. And your warm-up is to rearrange this formula so that you could use it to find an angle if you were given three sides. So the side, side, side situation. So let's say instead your triangle looks like this, where you actually know A, B, and little c, and you're trying to find this angle C. Pause the video and see if you can rearrange this to give you something that would give you that angle. All right, so if you're trying to get angle C, first we have to get this 2AB cosine stuff alone. So one thing I'm going to do actually, I'm going to add this to the other side, but first I'm going to subtract C squared to be with A squared plus B squared. So I've got A squared plus B squared. I'm subtracting C squared from that. Now I'm going to add this whole 2AB cosine C thing to the other side, just to make it positive. So there it is, it's over on the other side. Now, if I want to get the angle C, I have to first get cosine of C by itself, because C is trapped inside the cosine. So to do that, I'm going to have to divide both sides by 2AB. And if I do that, I'm left with cosine of C on the left, and now I'm dividing all that stuff on the right by 2AB. And it turns out most mathematicians are going to stop here. And this is the second law of cosines that you can use to solve for an angle. You just have to take the inverse cosine once you figure out what all this stuff comes out to. Now, at this point, I mean, you might take one look at this formula and be like, well, why would I use that when I could just use the law of sines? Well, actually, you can't use the law of sines if you don't have an angle and a side that are across from each other that you know. And this is not that situation. Another reason this is kind of nice is that it works in non-right triangles, and unlike the law of sines, and this is the awesome angle news, there is no ambiguous case with law of cosines for angles. Only one triangle can be formed given side angle side or a side 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 situation. So you don't have to worry about there being an alternate answer you have to check for. Whatever you get by the law of cosines in terms of angles is just the one answer. Now that we've gotten an introduction to the two versions of the law of cosines, everything that follows is pretty much just putting that into practice. So here's a triangle problem where you're trying to find this x side over here. And this is one of those situations you don't have a right triangle, so you know you have to use one of your special laws. You don't have an angle and a side that are across from each other that you know about. So really that just leaves the law of cosines. You have this side angle side situation and you want the opposite side. That is going to be law of cosines. So it's important to recognize that when you see it. So which law of cosines would be helpful here? Well, you could solve it with either one, but the most useful one is going to be the one that helps you solve for that third side, the one that looks like the Pythagorean theorem, c squared equals a squared plus b squared minus 2ab cosine c. So really all you have to do is just plug everything in and then solve for x. So doing that, we'll do this one together. Instead of c, that's actually the side you're looking for. So that's going to be x. Notice that it isn't necessarily the longest side of the triangle. It could be, but it doesn't have to be. That's what gives this a little bit more power over the original Pythagorean theorem. So we've got x squared instead of c squared. And then a and b are the other two sides, the legs of the angle that they gave you. So we've got 3 squared plus 6 squared. And then we're going to be subtracting 2 times a times b. So minus 2 times 3 times 6. And then multiply by the cosine of the angle between them, the cosine in this case of 46 degrees. So there's a whole lot of kind of intermediate simplifying that you could do. I very highly recommend that you just simplify that whole thing with the calculator on the right side before you get to square rooting anything. A lot of people, they like to do this in pieces and they mess up the PEMDAS. Just do everything on the right side here with your calculator. In fact, I'll do that now. So here I am on the calculator. I've got everything on the right side plugged in there. Let me just press enter, and as always, make sure you're in degrees mode here. So that comes out to, well, I'm going to round it off to the nearest tenth when I write it down as an intermediate step. So this is going to be 20.0. Got to be careful though. Remember, we still have an x squared on the left. We haven't actually solved for x yet. This is really just kind of a Pythagorean theorem setup. So in order to actually get x, I still need to square root both sides here. Square root this 20.0. Now, what I would recommend you do, if you've already got this kind of figured out in your calculator, instead of actually square rooting 20.0, I'm going to square root this stuff that my calculator just gave me. So I'm going to do square root, so second, and then this button to get square root. And now instead of typing all this in, if you have one of these graphers, you can press this up arrow and press enter to grab the input from before. And that puts it inside there for you. Now you can just press enter and get the exact value of 4.5 if we round off there. So it would have come out to 4.5 anyway, but it's nice just to get the most exact answer possible. For this next one, I'm going to give you a little bit of a backstory on your problem, and then you can try the problem on your own. So let's say the National Park Service wants to publish information on the diameter of Devil's Tower in Wyoming. Never been myself, but it looks pretty cool. Let's say we have two paths forking in the road, and they lead directly to opposite sides of the tower as shown below. We want to know how wide the tower is. So let's say that we know we have a 62-degree angle between the two paths, which you could measure with your protractor that you take with you on hikes. And let's say the one road here is 920 feet, and this other road is known to be 1,902 feet. We want to know the diameter of the tower, which let's say it's just this side of the triangle here. So this is a conceivable, possible real-life use of law of cosines. Pause the video and see if you can find that diameter. All right, so law of cosines we're going to use since we have a side angle side situation. We're going to use the c squared one. So it's this one again that looks like the Pythagorean theorem. So we can write x squared equals, and now a and b are the legs of the angle. So 920 squared plus 1902 squared minus 2 times 902 times 1902, actually 920 right there. And then we have the cosine of c, that's going to be the cosine of 62. Let's plug all this in our calculator to get the right side. So there we go, entered it all in. Again, I'm not doing it in parts, I'm just doing the whole thing all at once. Press enter, and that is a very large number, 2,821,003 we'll call it 0.8, but I'll really keep the value in the calculator. I'm just writing this down here as kind of a keep my place bookmark sort of thing. And then if we square root that, let's see what that ends up being. So square root, let me arrow up to grab that, press enter, and that's about 1,679.6, and that's in units of feet. We're going to do one more problem together, and then you can have an opportunity to practice some of the laws on your own. So this is the other situation we were talking about where you have all three sides and you're looking for an angle. So in this situation, the side, side, side situation, this is another one where you have to use law of cosines. Law of sines wouldn't help you here either because, again, you don't have an angle and a side that are across from each other that you actually know. So to start this one, since we're looking for an angle, we're going to use the cosine of c version of the law of cosines, this one right here. And as we're doing this, we're going to have to pick out what a, b, and c are. But first, at the very least, cosine of c in this situation, we're really trying to find the angle x. So we can write cosine of x equals big fraction, right? But now we have to figure out what a, b, and c are. Now, if you're used to using the Pythagorean theorem, then you know that c, the little c, is generally the longest side of the triangle. You have to kind of unlearn that on these problems. Remember, the law of cosines is meant to help you find the third side of any triangle, even if it's not like the hypotenuse you're looking for. So in this case, c is not necessarily the longest side. It's going to be always the side that's across from the angle that you're trying to find. So if we look at this triangle here, we're trying to find this angle down here. The side across from this angle, the opposite side, is this 12 over here. So in this problem, 12 is our little c. And then 5 and 15, those are going to be your a and your b. So a squared plus b squared means 5 squared plus 15 squared. And then we have minus 12 squared. And then down below, we've got 2 times the legs of the angle that you're trying to find. So 2 times 5 times 15. Now, just like with the other version of this law, I very highly recommend you just use the calculator to do any simplifying you're going to do on the right side before you take the inverse cosine of both sides and actually get the angle. So let me go to the calculator and plug all that in. So one thing you might find helpful is using alpha y equals and then picking that n over d to get your fancy fraction here. So we've got 5 squared plus 15 squared minus 12 squared. And then that's all going to be over 2 times 5 times 15. And if you press enter, your calculator in this fraction mode is just going to simplify that for you, if it can. So it gives us another fraction, 53 over 75. Great. So I'm going to write here cosine of x equals 53 over 75. Just kind of a nice little halfway step. But remember, we haven't actually found x yet. And this is the problem with both of these law of cosine laws. There's always something you have to do extra after you simplify the right side of it. So in this case, we need to do the inverse cosine. So going back to my calculator, we're going to do second cosine to get cosine inverse. And now I'm going to be a little sneaky, kind of like I did on the other example. I'm going to arrow up to my output from before, and I'm just going to press enter. And now, close the parentheses if you want, we can take the inverse cosine of that, which ends up giving us 45.0. And don't forget that is in degrees. And before we move on, it's worth repeating, even though we already said it, with law of cosines, you don't look for an alternate angle by subtracting from 180 or anything like that. There's no ambiguity. What you see is what you get. We'll do one more example, just to give you the satisfaction of resolving one of these on your own. Pause the video and find that angle. All right, so hopefully you remembered that when you have side, 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 you need the cosine of c, law of cosines, this one right here. So we have cosine of x equals some fraction, and then we always want to pick out a, b, and c before we go any further. Now, the angle is right here that we're looking for. So the side across from that, which happens to be 100, that's going to be our c value. Not because it's the biggest leg of the triangle, but because it is across from the angle that you are looking for. So that means a and b are 30 and 75. So we've got 30 squared plus 75 squared up there, minus 100 squared, all over 2 times 30 times 75. Plug that into the calculator. So here we go, making use of fancy fraction again. Alpha y equals, press enter. And that's going to be negative 139 over 180. So that's what the cosine of x equals. To get x itself, let's go back to our calculator. And we'll do second cosine grab the output that we just got and press enter on that. So that's going to be 140.6, and that is in degrees because that's an angle. So this concludes our lesson on law of cosines. Till next time, Mr. Sutton signing off.